Have you ever really watched a toddler play? There's this incredible, almost magical way they learn about the world. So what if we could teach an AI to be curious in that same way? Not just to follow our commands, but to actually want to learn on its own. Well, that's exactly what we're going to break down today.
You've definitely seen this in action. A little kid playing with blocks isn't following some lesson plan. They have this amazing instinct. They just gravitate towards the things that are right on the edge of what they can do. Not too easy, because that's boring, and not too hard, because that's just frustrating. It's this perfect little sweet spot for learning.
And really, that's their secret weapon, isn't it? This powerful, intrinsic motivation. They don't need a gold star or a grade to figure out what to try next. Their curiosity is the only guide they need, and it's brilliant. I mean, think about it. A kid who just figured out how to stack 2 blocks is naturally going to try for a third, right? And once they master walking, they start trying to run. This constant drive to find that perfect challenge, it's probably the most efficient learning engine on the entire planet. And for the longest time, it's been the one thing completely missing from AI.
So let's compare that beautiful, natural learning process with how we used to teach AI. Without that inner compass, an AI is just lost. It's adrift in this endless ocean of things it could possibly do. And the number of choices is just astronomical. In any kind of complex world, an AI could try something super easy, something totally impossible, or something that's just right. But without that internal guidance, how on earth is it supposed to know which is which? It's a huge, huge problem. And this right here really lays out the whole issue. The old ways were just so clunky. Letting an AI wander around randomly is just wildly inefficient. Trying to handcraft a curriculum for it, that doesn't adapt and it'll never scale. And making it chase rewards that we define just defeats the whole purpose of making an AI that can think for itself.
So, this is the big question. The million-dollar question, really. How do you take that beautiful, intuitive idea you get from watching a kid play and turn it into a simple, elegant piece of code? How do you formalize curiosity?
Okay, so the first piece of the puzzle is actually pretty simple. For any skill you want the AI to learn, you just track how often it's succeeding lately. We call this its competence. It's basically just answering the question, so how good am I at doing this thing right now?
But now, here's the magic trick. We don't actually care that much about the competence itself. What we really care about is how quickly that competence is changing. We call this learning progress, or LP. So it's not about how good you are, it's all about how fast you're improving. And this is the critical insight right here. We use the absolute value of that learning progress. Why? Because a big positive number means, wow, I'm really getting this. I'm learning fast. But a big negative number is just as important. It means, uh-oh, I'm getting worse at this. I must be forgetting how to do it. Both of those are incredibly powerful signals that tell the AI what it should focus on. And the algorithm that uses this is just beautiful in its simplicity. Our AI, who we call Juliet, spends about 40% of her time just exploring random things, to see what's out there. But the other 60% of the time, she focuses on whatever task has the highest learning progress. Whether that means she's getting better at something new or needs to go practice something she's getting rusty at. It's so elegant. Okay, so let's get to the results, because this is where it gets really, really cool. When you implement this one simple rule, you see this incredibly complex and sophisticated behavior just emerge, all on its own. For instance, you give a robotic arm this algorithm and just let it go, and what happens? It creates its own curriculum from scratch. First, it masters the easy stuff, like just reaching for things. But once its learning progress on that drops to 0, it gets bored and starts exploring again. It discovers it can push things. Then it learns to pick things up. And eventually, it figures out how to stack them. It's literally like watching a child's development in fast forward.
And it gets better. The system is smart enough to just ignore impossible tasks because, well, its learning progress on them is always 0. It automatically knows when it's forgetting a skill because that LP value starts to go negative. And maybe coolest of all, just like real kids, every time you run the simulation, the AI can learn things in a slightly different order. It's fascinating.
So, what about that forgetting signal? That negative learning progress? Well, it turns out to be super important. When you mess with the skill the AI has already mastered, the curious algorithm helps it get that skill back 45% faster than if it were just exploring randomly. And Mist's chart just lays it out crystal clear. Randomly stumbling around hoping to relearn something is slow and painful. But that targeted practice, which is triggered by the AI noticing, hey, I'm getting worse at this, is way, way more effective.
It's the AI's version of deciding it's time to hit the books.
So why is this all so important for building a general AI like Juliet? Well, because this simple, elegant algorithm becomes the very heart of her motivation. It's the engine. It's her inner drive.
And this isn't just for moving robot arms around. The Curious module is the central engine that guides Juliet's attention across everything she can possibly do, from running complex physics simulations to practicing her own reasoning skills.
So you can imagine, right? If she's making huge breakthroughs in understanding physics, her learning progress is sky high, so she's naturally going to want to spend more time there. But if she hits a wall on a coding problem and her LP flatlines, she gets bored, and her attention shifts to something more promising. It's a universal signal to guide her focus.
And this is where it gets kind of mind-blowing. You can map this simple number directly onto states that we would recognize as emotions. A high positive LP, that's like joy or deep curiosity. A high negative LP is like frustration, which motivates her to practice. And an LP near zero, that's just old-fashioned boredom.
And that's really the heart of it. Without this inner drive, an AI is just a passive tool. It sits there and waits for a human to give it an order. But with this curiosity module, she becomes a self-directed agent. She chooses her own goals, she finds her own weaknesses, and she has a genuine, built-in desire to learn and get better.
Which of course leaves us with one final, very exciting question to think about. Once you stop telling an AI exactly what to learn, and instead you just give it the drive to be curious, what incredible things might it discover all on its own?